Nobody can see you yet.
I just.
I don't know if it's.
I thought I dropped something.
I don't know if it's
Okay.
started yet or not. It says waiting. It says here start. So we'll. Yeah. I think it's going. Yeah. Oh, yeah. Okay. Okay, we are live.
We're live? Oh no, I wasn't ready. I want a do-over.
Just the other thing's a little bit delayed.
Okay,
so.
all right. Okay, well, we're working with two screens here, and one's got a delay on it. So,
Yeah.
I'm W1REX, Rex Harper, and
Stephen Hauser, N1SH.
And this is a live stream number 3, building a Cento Recevo no solder kit.
Yeah.
I think everybody was excited about that. The very first time I did a no solder kit was in 2016. And I did the world's biggest billathon at 4 days in May. We had 246 people. 246 people built a 20-meter transmitter in the ballroom with no soldering irons. That was the world's biggest billathon. So this is an offshoot. I've done many no solder kits since then. I've probably got 8 or 10 different designs. And I was at, as usual, I stand in the canned meat and fish, the canned meat and fish department at the store, and I look at cans and I just say, oh, what? And this one here, the Cento Receiveo. I mean, it's got to be one of the most gorgeous cans in the entire supermarket, right there. I mean, it's nice and yellow and red. It's got all kinds of stuff, and there's a blue one. 2 different kinds of anchovies. These are flat and these are rolled. The same company makes this beautiful tuna salad can. Unfortunately, it's not anywhere near as pretty on the sides as these are. See, even the sides are decorated nicely. So anyway, so when I saw that Cento anchovy, I just had to do a kit with it, and I had this receiver no solder design I had done for England. And so I repackaged it and designed it a little bit differently. And we have right here, which camera am I shooting? Top one, okay. Yeah. So we have the Cento receiver. And obviously, I mean, all you guys have already got one. So I'm preaching to the non-choir here. There are SIP strips and IC sockets with machine pins, and all the parts are inserted. We'll go to the close-up one. So all the parts are inserted right into the SIP pins, and I have to do a lot of special design work to get everything to work out geometrically and fit the circuit easy enough. So this billathon is for the, I don't know how many people. I think we had about 49 I think kits that went out the door for this billathon. So we're going to start with an empty pallet, which is this is the board, and I have done all the soldering. This is the no solder kit for you, but it's a solder kit for me because I have to put all these SIP pins on. And how I do that is with I have a soldering machine. I can do about, on this one I did 8 or 10 boards at a time. I can't remember how many I soldered up at the same time. So it goes pretty quick. So we're going to take this kit and we're going to start inserting the parts and see how it goes. Now I lied a little bit. I'm sorry. We're going to build the kit no solder. There's no solder involved except for me. Okay. But I did give you a homework assignment because while you can plug a, I'll show you. Let me get a part out.
Oh, yeah, let me go to the.
That's okay. I'm just off screen getting a.
You're on screen now.
I'm on screen now. Okay, I'm extracting a 9-volt battery snap, and you can actually put that. I'm going to install that on the board, and the pins go right in there. Okay, and it's installed, but it's a really flimsy connection. So I like to take and use a couple of little SIP pins and solder them to it. And this works on all my no solder kits. And so this is a handy dandy way of just plugging the 9-volt battery snap in there. Much better connection. So you had a homework assignment to make this little cable, which is a 9-volt battery to 2 SIP pins. And then we have another one, which is 2 alligator clips to a 2-pin SIP. And that's for the antenna connection over on this side. And as always, the problem with a receiver is you got to get headphones into it. And without having a headphone connector, there is on the board, there is 2 solder points right here that you can actually solder a headphone cable into those 2. Let me see. I got to get a pointer here.
Yep, it's right there.
Okay. You can solder them into these 2 things here, or these 2 SIPs on the end. So in other words, this one here will actually go into the SIP pins like this.
It's really good close up of your finger.
Okay. So that's one way of connecting it, but you could connect that, solder that right directly to those 2 pins. I like not soldering it to those pins. I like the SIP action because then you can sort of take it apart, put it in a little box, and you're not stressing the connectors.
And
okay.
Folks, feel free to post comments
yes.
in the chat and or questions, and we'll try to answer them there. I see Lamar just posted CQ. Hey.
Okay. Yeah, check in. It's nice we know who's here and who isn't.
Yeah, and if you got questions, there's a little bit of a lag from when you post your questions to when the video comes through. But
we'll see them and we'll answer them when we actually see them. And now the other thing I mentioned when you're making these cables is put a little hot glue down on the where you soldered into the SIP pins, and that forms a little mechanical handle plus a strain relief on the cable. So I got a little hot glue on each one of those cables. So, I mean, that's a fairly simple job, and it shouldn't tax anybody's soldering skills. But I must admit, you should be using a iron with a very, very small point on it.
Overhead camera.
Overhead camera?
Yeah. What?
Okay.
You don't have to put it that close.
Okay. See right there? I have a very fine point pencil iron. And that works great on SIP pins. If you get too big a point there, it's going to put too much heat on it and it's going to melt the plastic. Okay, so the other thing was prepping all the parts. So I told you that we had to form the parts, and I put up an updated parts list, bill of materials. I'm sorry, the sorting sheet. Pull that sorting sheet up for just a quick. Okay. All right. I'm sorry.
Sorting sheet.
The parts sorting, and I have to move my eyes over there to see if it's up on the screen.
It is.
I can't look over there. Okay, so that's the 2nd generation document that has the actual lead spacing of all the parts. Because we did have someone who was rambunctious and bent a lot of parts, not the right things, and I wasn't specific about that. So I should have done my homework and made the document better. So that's a better document. And then, of course, there's an insertion depth. These SIP sockets have about a 0.15 inch depth that you can plug something into. So on the little lead forming tool, you can use this fine little thing over on one side if you're really persnickety about your parts looking identical and all that kind of jazz. Like some of us are, right, Steve? Some of us.
Yep.
Okay. So you can actually cut the lengths of the leads so that they're all the same height, or the same length, so the parts all stay at the same height, which I did. Okay?
Of course.
So I did my homework, and here's what I've got right here. Okay? There are all the parts. Okay? I have cut them. I formed all the leads, and I cut the lengths, and I've got them in sorted in the shape of where they go on the board in order. So I can go one for one down the board and translate it to the part. That's how I sort it.
And was that on this list here, or you just had the list here?
I had the list of parts and how they had to be formed. Okay. Now I didn't tell you how to sort them. I mean, we had a problem with some people didn't recognize the chokes. They look like resistors. Well, chokes look like resistors. Okay, so I identified them with a picture on each part. Okay. Now in the bill of materials, the color codes are called out, but not what they look like. So this is what they look like what they're cut at for spacing, but not the actual color codes. I'll add those next time on a third
And
generation.
the bill of materials has just this. It's
Yeah,
the-
just that with not a picture. I assume
it does have the markings for the capacitors. Which
exactly.
is good, right?
Yeah, I marked the capacitors. I put the color
So,
codes for the
yeah.
resistors. But like for instance, where I failed is the choke axle inductor. See, brown,
Yeah.
black, black, silver, but it looks like a resistor.
Yeah,
Okay, so that's
except
all.
for they're greenish.
They're greenish. Sometimes they're tan. Okay.
Yeah.
So it depends on the series and the manufacturer. So now I got my parts all lined up. So did everybody do their homework and get their parts all formed and ready to insert?
Let's see. We got Earl from Alabama.
Yeah.
DD from I think Eastern PA. Or no, Doug. Doug from Eastern Pennsylvania. Yes, Al Sutton made it.
Hi Al, how you
Keep
doing?
Cool in Carolina.
Okay. All right. Well, we're just going to go ahead and continue on. How many people
Yep.
do we have in there so far?
15.
15. Well, they're going to join us in progress then. We're already 10 minutes into it and we haven't put a part in yet. So, so doing it this way here, you can go pretty quick. The one thing that same as soldering a kit, you always start with stuff that's laying down on the board that's close to the board, because when you start putting parts in, you don't want to have to put a little part in around taller parts.
Yeah.
So if you look at these parts here, you can see that the capacitors are all very, very low, and all the resistors and capacitors are high. So I'm going to go ahead and put in the capacitors first. It makes sense. So I'm going to take the first capacitor in the list.
Which capacitor is that?
It's the 0.1. It's right next to the 680 ohm resistor.
You say first in the list.
Okay, go to the bring up the Cento diagram, the Cento Recevo right there, that one. Okay, so here's you can look at the 3 rows: the top row, the middle row of sockets, and then the bottom row. Okay, now I'm not going to put in the 9-volt battery. See on the top row?
Yep.
I'm going to skip that. I'm going to skip the 680 ohm resistor because that's a hairpin, which is tall. So I'm going to go to the next one, which is a 0.1, which is short. So I'm going to go right where the 0.1 is.
That's
And-
the 0.1 capacitor.
Very carefully put that capacitor in, and there it is. One lone capacitor, the first.
So that matches how it is.
Right,
on the-
and there's the pictorial is right on the silk screen. It shows you exactly where that capacitor goes. Okay.
So you're in the 5th and 6th hole there.
Yep. Okay, and then right next to it is another capacitor, which is the 1.0. Now that's a tall one, so I'm going to skip that one too. Okay, because that's a can. Go back to the
So
parts
that's
here.
The 1.0.
Yeah, the 1.0 is a aluminum electrolytic. So that's got some height to it. So we're going to skip over that and go right to the next capacitor, which is the 100 picofarad, and that's got a little bent in it. That's got like a little oops, I dropped it. Sorry about that.
It's so small that's droppable.
Yeah, okay. See the little knees in it? Got a couple of knees on it. Okay. So I'm going to take that and put it in the 100 picofarad where it says 100. Okay. That sits a little bit higher because of those knees. You can't chop the knees off, unfortunately. So there's a resistor right next to it, the 27K. We're going to skip that. We're going to go to the other one with the knees, the 100 picofarad. We'll put that in there. And there it is.
So another 100.
Okay, so now I got 3 capacitors in there. Right next to is a 0.01, so I'll grab that, put that in. Okay, and next to that is a 0.1. I dropped that. That must be the one I dropped. Okay, hang in there. I thought one fell off. Fortunately, I brought another bag of parts.
For
So,
the 1.0, which way does the polarity go?
positive to the left.
Positive to the left.
Yeah.
Okay.
Okay. So we got a couple more resistors. I'm going right down the list there. I got a couple more tall resistors. Then we got a 0.1 again. So I'll go and get that 0.1 and put it in. Probably should have cut these at 0.2 inches just to give them a little bit more height. But the closer they are to the board, the more likely they are to stay put when you're carrying it around. So I'm going to bypass everything else in that row and move on to the next row, the bottom row. And I'm going to put the capacitors in down there. So I'll just move that aside. Again, I'm trying to get all these low parts.
We got a really weird scene going on. What's going on? There we go.
I don't know.
Yeah, sorry, it went
I'm
wacky
told
on me there
I'm
for a
told I'm
minute.
not supposed to look at the screen, so I can't look over there and see what's going on.
Went wacky on me there for a minute.
Okay.
Showing the screen and the screen and the screen.
Oh,
Sorry
okay.
about that.
All right. So down the bottom row, the first capacitor is a 27. Okay, it's the third item in. So I'll put the 27 there. And I always tell people in billathons that, you know, when they sort the parts, you know, they either they sort them like, in most cases, if you look at my bill of materials, I always have the resistors in the top left-hand corner of the bill of materials because they're the ones you typically put in first. And then the chokes are underneath those. And over on the right-hand side on the top are capacitors. And then down below that typically are anything extra. So I sort of keep them in a semi-sort. Now there's an X capacitor on this board, okay? And if you can see it, X, it's marked X.
It's down on the bottom.
It's down on the bottom row. See right next to the 27, there's an X. So you can't really...
and here the trace is covering it up.
Right. That's why there's another document that doesn't show up on Steve's computer for some strange reason, but it's on my phone and it's on my computer. It's Cento Receiveo Silk.
Yeah.
And that's just a black and white picture of that document with all the red stuff in it. No traces, no solder mask, and it's just the parts easily identifiable. But for some strange reason, his computer doesn't pull it up. So, all right, so that I'm going to skip that X because it doesn't exist. It's the unknown. Actually, if you put you can experiment depending upon your crystal. I find that with QRP ME crystals, that if I put about a 33 picofarad capacitor there, then the receiver is going to be right smack on the crystal. The frequency is marked on the crystal. If not, it will be slightly off. But it will happen with different crystals, and it's the difference between serial and parallel resonance on crystals. Okay, if you don't understand that, that's okay. All right, so I'm going to skip over and I'm going to do the 220 next. So there's an X that's missing. It's not used. 220 goes in there next. There it is. Now, I don't know. Am I going too fast? Anybody actually keeping up with me? No. I can tell already. I'm going way too fast. I said in my little outline to myself, I said I'm going to go slow. I can build this thing in about 5 minutes, but I'm going to try to slow it down. So I'll let people catch up. So give us some feedback where you are, if you're actually with me or not.
Sorry, I'm trying to get this going too.
Yeah. Okay.
Well, it's going to be a delay before people.
Yeah, I know there's going to be a delay.
You're going to have to sit around for a few minutes if that's what you.
Well, I'm going to sit around for a few minutes. I'll just do a little bit of talking. But so, you know, if we wanted to make this billathon, you know, 2 hours or 3 hours like the other ones, then, you know, we cut and place all the parts, you know, as we're building it. But in the cases of the no solder, I mean, we should be able to go quicker by prepping everything beforehand, which is what I attempted to tell everybody to do in a homework assignment.
Earl says no, so I assume that means no, he's not.
No, he's not with us. But as always, this will go instantly. It will be up on record.
Yeah.
It'll be right up on the website, so you can go back and rewatch it and pause it and, go at your own speed. Yeah. If you go back and look at all my sudden storm, this Cento Recevo is actually a sudden storm kit receiver. And I've been doing that. That was I think my second kit. The first kit was the tuna tin. And then I had the sudden storm, which was designed by George Dobbs, G3 not MFJ, I'm sorry, RJV. So this circuit's been around a long time. It's been around for about 15, 16 years, I guess.
So here's the
And
220, right?
every schematic of every one of my kits has a X right next to the 612 because it's sort of a fudge capacitor to make the crystal operate better. So I got the 220 right next to it.
John says he built it a few days ago. So
Yeah,
he's up to
I
speed.
know other people have built it already, so it's not hard. Okay, so I'll continue.
So you got the 220 in. Right?
Yeah, and I got the next one is an 01. Okay, so I've got an 01 in my hand from my sorting thing, and I'll put that in the pins. One thing when you're putting the pins into these sockets, there is a little recess in these SIP sockets before that hole. And so sometimes if you put a pin down in the socket and it's sitting on that recess and not in the hole, when you push it down, it's going to bend.
Yeah.
It's going to get mangled. So you want to sort of wiggle it with your finger to make sure that it's in the hole before you push on it. Yeah, before you push it down. Because I've done it myself. I say, I think it's there, and I push it down and it just folds over. So, okay, so the next one is a 033. So I got that one in my parts locator here, and I'll put the 033 in. Okay, push it down. Looks good. This is so much easier than soldering, isn't it? Of course, you spend a little time prepping your parts, but that's okay. Even in soldering, you got to prep the parts after the fact. Now we just do it before the fact.
Okay, now you're onto the 01.
I'm onto the 01 next, right next to it. And look at how fast that went in. Yep. Golly gee, that's fast. So the next one is a 0.1, which is class, a 0.1. Bueller. What's a 0.1 mark? Bueller. It's 104.
104.
Yes, 104 is a 0.1.
Sorry, that color's not showing up well.
Okay. So there's the 104. And right next to it now is a 33. We'll get the 33. And I'll put that in.
Wait, so you did 0.01. Then there's a
0.1. Yeah.
Okay.
Then there's a 33. Yeah. Okay. We ready? Oh, look at that traveling box.
Yep.
Okay, so the next one is a VAR, which is this black thing. It looks like a two-legged transistor, and that's actually a varactor diode. Ooh, geez.
Yep, there you go.
Okay, it's got a little mounded, and it's got a flat side and a little sort of a semi-rounded side. So the rounded side goes into the board, the flat side is out, and that goes in there. Now that's a varactor. That's a voltage-controlled capacitor, and that's what does the tuning.
Say that again. The flat side goes.
The flat side is out to the edge of the board.
So the flat side is out.
Hey, they can't see me.
Yeah, that's okay.
Oh, okay.
Flat side to the edge of the board.
Well, I'm making this movement here with my hand, showing, and I don't see it showing up on the screen. Yes, the flat side is to the outside edge of the board. Okay.
Flat side. Oops. So flat side is that way.
Right. Right. Okay. And if you don't get any tuning, you just turn it around. It will work. Okay. So the next capacitor is a 0.01 down. Skip the 100K and go to 0.01.
Here. Whee! See, I can do this little arrow that spins around.
Steve's having fun with the computer over there. Okay, I'm trying to get these little teeny things in. That's the only problem is sometimes they're hard to hold. Okay, if you don't have some fingernails. See, I got that spread just a little bit too wide, and it's not going into the hole very well. So
I was asking about the polarity. I think of the varactor. So
yeah.
I think we
Yeah, flat side to the outside of the outside edge of the can or the board. Okay, so that's the bottom row of short things. Now we look at the
So
there aren't any short things on the center line.
that's where we're at.
Yeah.
We've got the
See, this time we skipped all the resistors because they don't lie flat. They stand up. So they're high. So now we do all the capacitors first.
Yep.
Okay. And then once we do that, the next best thing, I guess, would be the resistors. So I can go back. Well, there is a diode in the middle one. Yeah, we'll put the diode in the middle.
The diode is in the...
Yeah, towards the end of that. There, it went by right there. Okay. So we'll get that diode because that lies really flat. And that's at 0.3 inch spacing. So it fits in a...
cathode is down.
Yeah.
So the end with the stripe.
End with a stripe is down to the bottom of the board. Now that's gonna slide right in.
Cathode goes in there. See the little stripe.
Okay, and that's very flat on the board. And everything else,
And that should be
pretty much everything. Oh,
so that
the
diode is between these two pins here. Just
yes.
in case people were confused.
Yeah, yeah, right there. Okay. Now the inductors are relatively low to the board too. So.
And those are in the middle as well.
Yeah.
I
See
that
L.
right here.
Yeah. See that's L2, and the one right there is L1.
Right here.
That's why it would help if one saw the actual schematics. I mean the silk drawing instead of this thing. So I'm going to put L1 in first. Now I want to tell you that this sudden storm kit, all you have to do is change the crystal. Okay, I'm making sure this thing fits before I push it down. One of the things is not going into a hole. The bottom one. Okay, there it is. Okay, so if you change the two inductors, okay, and change the crystal, and change this 127 picofarad capacitor down on the end, you can change the band on this. So right now we got a 40 meter receiver, and you could make it a 20 meter receiver by changing the crystal, the two chokes, and that 27 picofarad. And if you go to the documentation on the website below it, okay, let's quickly go to the this is important because this is important stuff. Yeah, right there, original SS instructions. Okay, let's cycle down there a little bit. Keep on going to the schematic. Right. Okay, I'll keep on going. Let's see about. Keep on going. Maybe it doesn't call for it here. Up. Here we go. Okay. Scroll down just a little bit. Right there. Okay. You can see that L1, we just put in a 10 microfarad because we got a 40 meter kit. But see, you can change it to 6.8 or 22, depending upon if you want to go to 80, 40, 30, or 20. Go down a little bit further to L2, and there's the L2 value, 22, 10, 10, and 6.8. So those are the L values, the chokes for the two bands, or the four bands. Change the crystal, and then someplace it's going to talk about the 27 picofarad. And I have to go back and look. I think that's probably further up. It might tell you what it is.
Well, it's installing the capacitors here.
Yeah, let's see where it goes to the 27. This is a very old document here because this is one of the very first kits I did. You can see it's a single-sided far circuit board.
Well, it's in here somewhere.
It's in there. Okay, I'll clear that up and let you know. I was thinking about having a little bag of accessory parts so that you could actually make this thing work on other bands. So, but the thing I was trying to allude to is the fact that you can make these a little bit taller, these chokes, so that you actually have a handle to pull them in and out. because, if you want to change that band, if that's a little bit higher, then you can grab it and pull it. Okay. So that's why I was trying to go there, and say these might want to be a little bit higher in real life, because you might want to have them, you might want to change the bands. Now this is where I have to wiggle those things to make sure they're in before I push them down.
So you're putting in L.
I'm putting in L2 now.
Which is here. Which is right here.
Okay, L2's in. Okay. So the other things that are flat are the two ICs. Let's do the two ICs next. Okay. See, what I'm doing is I'm looking. Okay. Go back to our overhead shot here. I'm looking at my parts. Oh, that's a bad.
Yeah.
That is really bad. Hold on a second. I'm looking. See, here are the parts remaining on. Let me get the. Okay. Here are the parts remaining on this strip. And here are the parts on this.
Just leave it down on the.
Yeah. Okay. All right. So here's the parts on the.
Leave it down.
And here's the bottom strip. This is the top strip, and this is the middle strip. So I'm looking at the parts heights, and I'm saying, okay, I'm going from short to tall. So I'm going to go back and say, well, here are the two ICs. They're pretty short, so I'm going to put those in. Now these are tricky because brand new ICs have got, nope. Let's see if this works.
It was fine. That's fine.
That's fine?
Yep.
Okay. If you look at the legs on the ICs, they're splayed out. They're not 90 degrees vertical. So what you have to do is very carefully roll these things. And I put them on the table, and I roll it both sides until it looks like they're vertical. And now I can look at those legs and I can see that they're straight. Oh, there we go. There's the shot right there, the money shot. See, they're straight up and down now instead of flaring out. So now they should be able to wiggle into this connector. So this is what you do on any IC that you're putting into a socket. You have to do that on all of them. And I can see that one leg did not really want to go down in there very well. So I'm going to lift the part up and see it's bent a little bit. So I'm going to straighten it out and bend it at the 90 degrees. Try it again. And this time I'm going to make sure that that pin goes in before all the other ones. There it is. Okay, so that IC is in.
And pay attention to where the little
dimple, the dimple matches the dimple on the.
and it's to the left as well.
Yeah. Right here.
Yep.
See, there's a little semicircle right there.
Little dimple there that should match the dimple there.
Yeah, some of them don't have a really pronounced dimple on them, but so okay, so I got the other IC. I'll do the same thing.
Mention the position orientation of the IC. Oh, I think that's what we just did.
Yeah. So those look like they're 90 degrees. This has got.
Are both ICs the same?
No. This is the mixer, Gilbert cell mixer. Okay, the 612, and this is a LM36 amplifier.
Okay.
And now
they got the same number of pins.
Same number of pins.
Okay.
If you look at this one,
So be careful. Put them in the right spot.
yes, put them in the right spot. They will not like each
Because
other.
we just put in the 612.
This is the 612 over in the first.
And you can see it says 612 on the board right
Yep.
there, hopefully.
Yeah.
So, and there's the little dimple on the board. So, yeah.
Yeah,
612.
the 612 has a dimple. The LM36 does not have a dimple on it. Okay. But it has a round depression.
Hold on.
Let's see how close we can get this.
Yep.
Oh,
right
did
there.
you see the
Yep,
little?
Yep. There's a little. Yep. Stop. Yep, there we go. Right there.
Right there. There's that flash of that. That's the round dimple is pin number 1.
And it's in the bottom left-hand corner. If the
Right.
text
That's
is
pin number
upright.
1.
Yep.
Yep. Okay.
So that's the side with the dimple.
Right. That's the dimple end. And if you look, then you can find where it goes in here.
And it goes furthest to the left in that socket.
Yeah. Again, yeah, you can see it's, yeah, furthest to the left. LM386 it says.
Earl says his says NE 602.
Ooh, how'd you get a 602?
Yours-
Oh, the schematic probably, the layout probably says 602. It's a 602, 612. They're universal.
Yeah, this
602 is the old one. 612 is the commercial version.
This is an SA 612.
Yep.
And then here over here is the LM 386.
Yeah, I copied that. I copied the nomenclature from the back in the day. We didn't have 612s. We had 602s, and they stopped making 602s, and they started making a commercial version, which is a 612.
Right.
So they're the same chip. Okay, just different temperature ranges. That's all. So now I've gone through most of my parts that are low, and now I can put in the high ones as I go along. So I'll go back to my first row, and I'll just go right down the line. I'll pick the first resistor, and I'll put it in. That's the 680 ohm resistor.
And that's 680 ohm resistor. So that's right there.
Now, this is the one you bent as a hairpin, so you want to make sure that you get it started in the hole right, so that it doesn't bend up on you. And that's what these little, the 2-pin hole is right here. You can.
I was trying to show the. No, oh, I thought you had it in there already.
No, because it's not wanting to bend. So I put it in there, and I'm just sort of bending it parallel. It was flared out a little bit, so it didn't want to go into the second hole, so I just there. See, it just popped right in. After I got the leads 0.1 on center, okay. So I'll put the 1.0, and the plus is to the left.
So, and this is the electrolytic.
Electrolytic.
And a 1.0. So that's
Yep.
this one here, right?
Yep.
And
Okay.
the polarity you said?
Yeah. Well, the negative is the big stripe. The negative is to the right. Okay.
Negative to the right.
Negative to the right. All right. Because it's
Positive to the left.
right. Okay. So the next one on the list is the 27K resistor.
Okay.
A little bit further down, 2 parts down. So here's my 27K. And I show the body to the left, but it doesn't, to the right, it doesn't make any difference, but I'll just put it the way it's marked. And there it is. It's in. Okay. The next one on my sheet is the blue bodied.
So we just did the 27K.
Yeah. Now I got 100K.
Another hairpin.
Another hairpin resistor. We call that hairpin because it looks like a bobby pin. Okay. So there's that. See, top row is getting fairly well populated. And I haven't had to work around other things. It's been quite natural. So the next one is the 22 ohm resistor right next to it. I'll turn that and make it oriented right and put that in there. Okay. Oops. Okay. And then we have a last 10 ohm resistor. And I'll put that one in. Whoops. That one wanted to bend a little bit, so.
Okay, you whooped off camera. Nobody saw it.
Nobody saw it?
Yeah.
Nobody sees me fixing this thing?
Nope.
Okay.
Not yet, anyway.
Okay. Oh, let's see. I tried to finesse it, and it didn't go. So I'm rebending the leads again. And okay, we'll get this in here. Third time's a charm. Oh, right in. Okay. And the last one on that row is this 100 microfarad capacitor with 0.2-inch spacing.
And that's
Negative,
a pretty big one.
negative to the right.
So
Right.
do you skip a hole in the middle? Is that what's going
Yep.
on there?
Skip a hole in the middle.
So this hole right here in the middle, nothing goes into. It goes into the two around it.
Yep. You try to, I mean, that was the key of laying this thing out. And you notice there's actually, there's one hole on that whole strip that's not being used. So I had to, that's the geometry and the puzzle making of laying out a kit, is to try to optimize the number of pins and the layout so everything works nicely. So that top row is all done. There's all the parts.
And that one does have the polarity marked, which is positive
Yes.
to the left again.
Positive to the left, negative to the right.
So hopefully people got that so far.
Okay, everybody. Okay, you don't have to be with me. It'd be nice if everybody caught up to me. Okay, I'm gonna put that strip aside. My elbow was laying in all this bag of parts here. Okay, so now we got the center. The center is we need to populate.
Okay.
Okay. All right. So we'll start with the crystal. Again, I've already pre-bent these in my homework assignment. I used my little handy dandy little lead bender, and this
the
is
crystal is
this is a 7030, and it's the second it's the second socket in the center.
Yeah.
It's
Point to where you're going to put it. No, on your board. You're going to put it right there.
It's right at the very, it's right at the very first two pins of that center.
So right here.
Yep.
Yeah, people can probably see it better on their board than I can see it on this.
Yes. That's why that second document is supposed to be important, but for some strange reason, it's not showing up.
Okay. Well,
Okay. So now we go to this. The next one down there is the top.
Well, then you've got your two things that you've already put in.
Right.
Or three things, because you've already put the diode in too.
Right, but right between the choke and the choke and the diode on the top row, where you got the blue,
Yeah, right there.
right in there is another capacitor.
And
That's a 10. Yeah, and again, positive is to the right and negative is to the left.
So it's another electrolytic.
Another electrolytic. There she is. Okay, so now we're down to the tail end of the third socket in the middle section. See, there's a 2N7000 above. And you notice, see the half round is to the top.
Right there. So the flat part goes in. Right?
Yeah, flat part is towards the center of the board. Round part is to the top. Ooh, look at that. I'm running into the big capacitor up above, so I probably should have put this in before, but I can get it in there.
And that board is, well, the way you're holding it, it's upside right for you, but upside down for everyone else. So
here we go.
No,
Here we go. There's the top side, and there's the 2N7000 right there.
Yep.
Just before
the last hole.
the last
So it
hole,
doesn't
which
go
is
into
where
the
the
last hole.
headphone
Yeah,
goes.
that's where your headphone.
Down below, there's another 100 microfarad. So I got the 100 microfarad. Negative to the left and positive to the right. So I'll put that in. There it is. Okay. Cooking with gas here. So now on the bottom row, we've got a 10K gain pot over here at the very leftmost side. So we'll put the pot facing out.
So you can turn it.
So you can turn it. easily. That's actually, it's not really a gain, it's actually an attenuator pot. In case you're listening to a very, very strong station, you might want to turn the attenuation down because
In case you found somebody from Missouri putting out 1,500 watts or something
yeah.
like that.
Well, actually, if you got a high powered station and you got a low station, if you attenuate a high station and bring it down, sometimes you can actually discern the second station a lot easier when it's
Yeah.
when you're not being auditorily blinded by the first one. Okay, so we got one more resistor, the 100K down here in the end. So I'm going to put that in.
100K. That's right over here. And then you got another pot down there, right?
Yeah. And come on.
The 1N418 diode is the smallest glass piece. Is
Yeah.
it a glass one?
Yeah, it's a glass
okay,
diode.
Yeah, it is a glass one. And it's got a red mark, right? Or is it red or black?
It's black. It's got one end of it's black. That's the stripe.
Yeah, okay.
This is surprisingly, these hairpins are the one that's giving me the trouble. And I can see that it's flared out just a little bit. So I'm going to use my pliers to sort of bend it in and make it parallel. And I bet you it'll go in again real easy. Right in. And then the last potentiometer on the end. And that kit is built.
I think it looks better. Yeah, I think you get better light on it up here like that.
Yes. Twist it, just bend it a little bit.
Oh, so you don't have an X.
Don't have an X. No.
The X one's not in.
Now I could put, as I said, I could put about a 33 picofarad capacitor in there, and then when I put in a 7030 crystal, it would actually most likely read closer to 7030.
Yep.
Then it will leave a regular crystal in that circuit will probably run at 7029.
Yep.
Or 70285, someone's in that neck of the woods. Okay. So all we got to do to make this thing happen is put all the 3 little cables on it and crank it up. Now, putting it in a can, here's what you probably want to do. I lay the board on the can like this. Here's an empty can. That's the next thing you got. You got to clean out your can, throw away the anchovies or eat them if you like anchovies. Make a pizza, put them on. And what I do is I have very fine Sharpies and go right down through the hole, and it'll leave a mark on the can. See the mark on the can right there?
Yep.
And then drill a very small hole for, this is a number 6 bolt, so you want to use a I think it's a 138 0.138 drill bit. I can't remember what number it is.
No, it's 3/8.
Huh?
3/8?
No. It's a little bit more than a number 4 bolt is an 1/8 of an inch.
Hit it with a center.
I think it's
first.
9/64. I think is what it is.
Hit it with a center punch first, so your drill bit doesn't wander.
Well, yeah. It's actually a lot easier to use step drills. Get the smallest step drill that you can find. At Harbor Freight, it's got a package of 3 for $10, and the one of them's got very tall, lots of variations, and the very small ones are what you're really looking for, the very small end. And then you drill a hole in there. And sometimes if you put a little block of wood here, so this is actually up high, and so you're holding it down, the block of wood is underneath, and you drill through there, and that way it doesn't bend.
Yep.
Now, here's the other one last point is when I use my wave solder machine to solder all the connectors on, that hole, and these 2 holes for the thing, they get flowed with solder. So what you have to do is take a hot iron, and I'm going to do this. I'm going to show you how you put something on your workbench, and this is filled with solder now, and you just basically poke it right through like that, and then you whack it like that, and it'll open up the hole. And you might have to do that a couple of times, but you can clean it up and get the hole open. And you only need one hole. You only need one hole to mount the bolt. And for instance, here's mine. See, down below, and just one little bolt right there holding it together. Okay, so here's the one we just built, and I'm not going to put it in any case. Okay, yeah, all right, that's good. So I'll stick the 9-volt battery, and there's a polarity on it, minus and positive. So there's the polarity for the battery. I'll stick the headphone jack on the end. There it is. And I'll hit my, now here's one that I think I included the alligator clips, I think. I can't remember. Did I? I guess not. I don't know. I think maybe I told you to go out and, I have alligator things from, Hamfest and everything. So I made one like that too. So you can plug that in. And again, if you do your ground and your antenna, which is the other way around, so you plug it in this way, antenna is yellow, ground is green. So you hook it up to your long wire, put your headphones to it, 9-volt battery, and there's your tune and your attenuation, and you should hear signals. I'm telling you, this receiver works. I think it was 2010, I think it was. George Dobbs, who designed the Cento Receiver. He and, Ken Evans, who was the president of ARCI, QRP Club, and we did a joint bill-a-thon at Dayton at 4 Days in May, where we built this receiver just as we have it here, from scratch.
Yeah.
Manhattan style, gluing down the board, the pads and everything.
Yeah.
And I mean, every one of them worked out the door. And we had the antenna was a clip lead going to like a 24-inch alligator clip, and we clipped it to the coil on the soldering iron holder. And we had a ground and headphones, and we were sitting in Dayton, Ohio, and we were hearing West Virginia, Kentucky, Tennessee. We had all kinds of stuff, and we had nothing for an antenna, but just a 24-inch piece of wire. So it does work. All right, that's all it takes to build this. Now, if you're interested, now here's the other thing about this: you can take this apart carefully, because those SIP pins want to grab the parts, but if you can carefully get it out, and you can build it again, or you can give it to somebody else and build it, or you can just you can demonstrate how you can reuse the kit and do it again.
Didn't see any more questions coming in.
Come on, I haven't answered hardly any questions.
Well, yeah, we had a few, but
I'm not supposed to look at the computer screen, so I don't know what they are until someone tells me.
nope, those are the ones. Earl was the last one with the.
Come on, hit me with some sort of a question. Come on, somebody.
Put the 2N7000
1,000, yeah,
backwards, and it still worked. Didn't see it on the sudden storm schematic. Huh. That was John. You were saying, I think it was, sounded like he put the diode in backwards and it still worked. Said he didn't see it on the sudden storm schematic though.
The 2N7000?
Yeah.
That's actually, the 2N7000 is for a muting circuit. Okay.
Yeah.
And yes, you'll see no mute on that audio there. Okay, but if you go to another sudden storm, a slightly newer version, and it's actually on the board. You want me to show the board? No, on the board down below right next to the diode, at the bottom of the diode, there is I wish I had a pointer.
Just use the pen.
Okay, right here. You can see there's a 2-pin
The mute.
that says mute on it.
Yeah.
Okay. you can actually that and the diode and the 2N7000 form a muting circuit. So when you're transmitting, okay, you can actually engage the mute function, and it'll kill the receiver, so you don't hear your transmit in your ear.
Huh.
Okay. Then when you unsupply the mute voltage, I think mute's a ground.
Yeah.
Okay, so it grounds the 2N7000, which shorts out the audio, something of that nature. I can't remember exactly how, but typically you're not going to use it on the receiver unless you get involved, and then you have to do some research.
So M&G says his kit suffered from motor boating until I installed a 68 picofarad in the X position. Is this a common problem?
Ooh, that's interesting. I've never heard anybody.
John Putnam said he got some motor boating as well.
Yes.
The other thing was he found the crystal leads were a bit too loose in the socket. Man, usually those crystal leads will stab you to death.
They will, but they are smaller than a regular part lead. So sometimes if the problem is if you put solder on them, then it will gum up the works and the grabbing mechanism for taking them in and out.
Yeah.
So what I typically do is I take my really nice blue pliers with nice serrated teeth on them.
Yeah.
And I try to mash the leads.
Just bend them so that
mash them, so flatten them out a little bit and make them make them a little bit more grabby. Okay, that's what I've done in the past.
Imagi says he ended up soldering it right to the SIP.
Well, now the other thing is you can solder it to another SIP
and then stick
it in just like the headphones.
Yeah.
Because you don't want to give up the capability of changing the crystal.
Yeah.
So
apparently he did. Well, I mean, you can always unsolder it.
You can always unsolder it. Okay. You can get more SIP sockets.
Yeah.
I probably should include more SIP sockets.
Just a couple extras in case.
I'll have to make a I'll make up a little package of some SIP stuff, and maybe the chokes and the capacitors so that you could actually change the band.
Yeah.
But it is a very, very useful circuit, and you can look at this. It's one of the most copied circuits under the sun is the Sudden receiver, and that was designed by George Dobbs, and it's named Sudden because he was a vicar in the village of Sudden, and he's like the godfather of QRP. I mean, one of the godfathers. I mean, there's quite a few of them, but I mean, he was a big emissary for low power construction, and so it's called the Sudden, but it's been redone over and over again by 9,000 people. I left Sudden in the name and put Storm at the end, so everybody knew it was a Sudden. And in my nautical theme of my tuna can stuff, I put a Storm at the end. But I mean the tiny tornadoes. There's 9 million variations that use that same circuit, the Sudden receiver, and it just works. It's a nice, simple circuit that works. And the reason I use it is because it's low parts count, and so something like this kit right here, a more complicated receiver would be talking tomorrow, and the day after would be doing a 3-day billathon. It doesn't lend itself very well to simple construction.
So making sure about placement of one UF. Oh wait, am I looking at?
Yeah. Wait. One microfarad on the top row.
Of 1 UF microfarad electrolytic between 0.01 and 100.
Yeah. The third part on it's third part on the top. It's clearly marked 1.0.
Whoops, that's the wrong one. That.
Yeah, top row. Next to it. Right there, 1.0. Okay. Now,
it's
okay.
The 0.1
let's go to the schematic. If in doubt, you always go to the schematic and take a look at. I guess it didn't make a schematic of this particular kit.
Earl says thanks. That's what he was looking for.
Oh, okay.
We're good.
All right. Okay, we're good. That's the original design, but this is a little bit different. So if you go to my sudden storm page, you can go back and look at all the variations over the 25 years I've been doing kits. And the current version of the sudden storm is version 8.
Yeah.
So I've gone through 8 variations of the theme, and I think this is probably a combination of the early one with the individual chokes and whatnot, no band module, and number 4, I think, which has the muting function. So it's a muting function and a couple other things, but yeah.
Cool. Oh,
So that's it, and there are. I have. I can allude. Should I allude to something new? Something coming up? I'm in love with this can. I'm sorry. I really like this can. And this is the first one. Go back to my video right here. This is the first one I bought, the Cento Blue. And I didn't, that's the only one I saw. It was on the shelf of a grocery store, and it was the only can, the only Cento can, and the only can they had. So they only had the flat anchovies. I bought it, and then I designed this board, and then I discovered that I went back to get some more, and I couldn't find any. I couldn't find a one. So I went looking around, and I finally discovered that the red can is much more plentiful, and I found some place that had a whole bunch of them, and I ended up buying what? At the Ocean State job lots, I bought 110 cans. The lady thought I was nuts. And of course I am nuts. I am a lunatic, okay? So I got these, and I bought some more of these. So, and of course this is a receiver, so it kind of begs to be paired up with something.
an antenna tuner. No.
No, a
A
transmitter.
transmitter.
A transmitter. So I actually have a transmitter, the board already designed in blue, so it will match up with this guy, and it's on its way.
Is that going to be a no solder kit as well?
It is designed as a no solder kit.
Okay.
I got a no solder transmitter, and I have
So that's what you can look forward to next, a matching pair of
actually
Cento Transo
I
and
can't-
Cento Receivo.
I can't remember if it's a no solder or not.
Okay.
Think. Jeez, I'm it's that because one of the things about this whole Billathon series is I'm trying to show various kinds of construction for simple projects, and
Yeah.
the next thing on my list is limerick construction.
Just put the
So,
board on the screen.
Limerick construction is like Manhattan construction in the fact that you put down squares and you put down the parts in the squares, you solder to the squares. But in Limerick construction, the squares are there and the interconnect is all there. So it's just basically, if you got a resistor, it's got 2 pins, you got 2 squares, and you just put the resistor on the pads, and that's it. And you keep on going.
Yeah.
You put the parts down, the kit is done. The first Limerick construction I did, I designed was way back when Michael Rainey introduced the Reggie, and I designed the whole Reggie on modules that you could build small mini parts of it at the same time, one at a time, and then connect them together. And so I did that, and I sent the kit down to Dave Ingram, K4TWJ, who wrote the QRP column in CQ magazine.
Yeah.
And he called me back at a couple of nights later, and he said he just thought that Limerick construction was great because he built the kit, and it was done at, I think it was 30 meters was the kit that was designed at 30 meters or 20 meters, I forget what. And he wanted to move it someplace else, and he said, geez, all I had to do was lift up the parts and put a new part in. He was, nothing fell off of other, when you got typical Manhattan construction where you've got 4 or 5 things coming to a single pad, you try to lift something and 4 other things come unconnected. But in this case, one part comes off and another part goes in its place, and he thought that was just so slick. So anyway, I've done mini limerick construction kits and I've done minis no solder kits. So you can look them, you can find them. I think there's a category on my webpage that says no solder up at the top. Go to home. Then scroll down and see if there's a no solder. Nope, they're right there, no solder. Whoops, uh-oh. No, that's me. I must have made a change to it. Can't find that page. I'll fix it.
Yep.
But I got a lot of different kits are no solder, and they're all listed on that page. I'll fix that. Okay, well, we're done. I mean, that is an hour and 5 minutes.
Yep.
Okay, we could have done it in 15, but I had to go slow. Is everybody with me?
No, we're shutting it down.
We're shutting it down, but how many people do we have when we're shutting down here?
We had 20.
20. Okay. Well, that's half the population.
Yeah.
Okay. All right, gang. Well, this will go up.
Time.
This will go up on the website, on the YouTube website, and there'll be a link on the Cento Receiveo page, so you can find it.